All right, well, welcome everyone to another PSL demo day. Today I will be the host and presenter. I am Jason DeBacker. I'm an associate professor of economics at the University of South Carolina. I'm president of the PSL Foundation, and in the Policy Simulation Library, I help maintain a few catalog projects: Tax Calculator, Cost of Capital Calculator, OGCore, and OGUSA. And today I'm going to be talking about OGCore, kind of a high-level overview about this project. Let me share my screen here. All right, so OGCore is a PSL cataloged project. It is a overlapping generations model, and it's a general framework for general equilibrium overlapping generations model with the intention to be able to analyze fiscal policy, both tax and spending policy. So this model has the ability to simulate a wide variety of tax and spending policies. It models the short and the long run. It shows effects on the macroeconomy as well as distributional impacts, both in the cross section and across generations. And it also allows for dynamic revenue estimates.
Jason, can I insert something really quickly? Just
please, Rick. Yeah.
For the people attending, you can stop and unmute and ask a question, or you can put it in the chat. I'll monitor the chat while Jason's presenting. And so feel free to ask questions during the presentation via chat or just unmuting.
Perfect. Thank you, Rick. All right, so questions a model like this might answer are questions of whether a particular change in law raises or loses revenue and by how much, whether and by how much a policy change might affect the macroeconomy, such as GDP growth rates. It can look at projections for the national debt, as well as look at the distributional impacts, i.e. who bears the burden of a particular tax or spending policy change. So some example output, and these are kind of derived from functions that produce tables or plots from OGCore. So here is a table of revenue estimates decomposing the percentage change in revenue between the static and the dynamic and the total effects of a policy change. Macroeconomic effects are another output of this model, where you can look at overall changes in GDP as well as components of GDP and changes in aggregate prices such as interest rates and the wage rate. Debt forecasts are possible in this model, and it's got a nice feature of having a closure rule that allows for temporary budget deficits, but long-run fiscal sustainability. And then there's distributional impacts. Here we're looking at kind of changes in before tax income across agents of different skill levels denoted by their percentile in the skill distribution. Okay, so those are just some examples of output from the OGCore model. Some more specifics about this model: it's a heterogeneous agent model with endogenous savings and labor supply. It has realistic demographics and mortality risk. It has the ability to represent the economy as a small open, large open, or closed economy. Those are all different parameterizations of the model. As mentioned before, it allows the government to run budget deficits and the user to specify how those budgets are closed in the long run. It has very detailed tax policy parameters for income, payroll, consumption, wealth, and estate taxes. It's able to model public pensions and, again, allow for transitory policy, and it solves for the equilibrium of the economy in the long run steady state, as well as the transition from the current period to that long run steady state. All right, so let me give now a little bit more background on why we have this general model, this OGCore model. And Rick Evans and I, we've been maintaining and developing the OGUSA model for years with contributions from others. But more recently, we found ourselves working with very similar overlapping generations models for a number of countries: Italy, Germany, India, the United Kingdom. And as we worked on these different projects, there was a lot of code to maintain and keep track of. We noticed that a lot of the code was just replicated across these projects. So we kind of came to the realization that the economic model is just a system of equations and a bunch of parameters, and those systems of equations and parameters are general across these different modeling environments here, in this case, across these different national economies. The only thing that's specific to those national economies are the particular values of the parameters chosen, okay? So with that, we decided to create this OGCore model that provides the general framework, has essentially the general set of equations and the general structure of parameters in this model. And then there are country-specific applications of this general model, okay? So we'll show a little bit how that works. But kind of with this, and with the development of OGCore, realizing that all this model is a system of equations and some parameter values, we developed the OGCore framework to be really easy to work with. Here's an example script, kind of the minimal working example of OGCore. And it's just 4 lines here, 2 of which are importing modules or classes from the OGCore package. But once those are imported, all one needs to do is instantiate a parameters object for the model, and then pass that to a function that solves the model. So you're just passing a set of parameters, in this case, some default parameters, to the equilibrium solution here. This is solving that runner function you see called in the last line. That's solving all of the equations necessary to compute the equilibrium in the short and long run in this overlapping generations model. Now, one would obviously want to update these parameters from their default values to take into account any specific application here, and that's again quite easy to do in this framework we've developed. Here you can see I've added to the prior script just 1 line here. That is the update parameters line. So we're taking that parameters object and we're calling the update specifications method, and we pass it a dictionary, in this case with just 2 key value pairs, updating the start year and the corporate income tax rate. We pass that updated parameters to the model, and off it goes, solving the system of equations that represent this economy. Now, OGCore, of course, because we want it to be general and model many different economies, it has many different parameters whose values can be changed to suit whatever application one wishes to. So there's literally thousands of parameters in OGCore. These cover everything from preferences of households to firm production functions to policy parameters such as tax policy or spending policies, and then parameters related to the model solution algorithms such as the rate of convergence and so on. So OGCore's parameters object, therefore, is a pretty complicated object in terms of what it's able to do. We're using functionality here from another policy simulation library catalog project called Param Tools. So the specifications object in OGCore that was illustrated in those prior 2 scripts, that is a Param Tools parameters object, which is really helpful because it has, that Param Tools parameters object comes with some nice functionality, such as being able to read in parameters from a JSON file or have them specified in a Python dictionary, as was illustrated on the prior slide. Param Tools gives us model validation, or parameter validation in this case, which is really important to make sure that when a user enters parameters, the model has been tested to be solved with those parameter values. And this includes complicated conditional validation, so making sure that a user is entering parameters that are consistent with one another. The Param Tools object also carries around parameter metadata, so a user can get information about what a specific parameter means, what the default value might be, what the range of possible values they could use are, and so on. And then, as illustrated on the previous slide, it's very easy to update this parameters object with methods that are inherited from the Param Tools parameters class. So that OGCore model, again, it's just a system of equations and a number of parameters, all of which can be updated quite easily. And it's intended that this OGCore package will be used with country-specific applications. So there's a few current country-specific applications that are in use, the OGUSA model, as well as the OGUK model. We have planned, Rick and I are working with the World Bank to help develop models for India and Malaysia as well. And again, the goal is to have many other, hopefully in the future, country-specific applications. And we wanted to develop OGCore in a way that it's easy for others to adopt this model to a country that they're interested in analyzing. Okay. So let me provide a brief example of how to use a country-specific application. So again, kind of working off the minimal working example provided in the prior slides. Here we are importing a couple of things from OGCore, the runner method, and the specifications class. We instantiate our specifications object, and then we run the update specifications method. Here, in this case, pointing to a JSON file that holds the default parameters for the United Kingdom. All right, so we're just going to read in that JSON file by pointing to the path where it exists, and that update specifications will be able to turn that into a dictionary, updating the parameters object. And again, we call the runner function to execute this model. Now, in this case, modeling the United Kingdom.
Jason, can I insert something? There's a question from Ekaterina, and it says, if you're not going to focus on this later in the PowerPoint, question one, how detailed can the sectors be in this model? And two, is there any way you could try to model informality so it is meaningful on the fiscal policy side?
Mm-hmm. It's a great question. So currently the OGCore framework has just one production sector. Planned in the next year is the development of multiple production sectors, and the ability, in that case, one of those production sectors would be an informal sector of the economy, which would face different tax burden, as well as have different outputs than the formal sector. So that's in development, but not currently in OGCore. What I will touch on,
that is specifically one of the deliverables for the World Bank for that project that includes right now India and Malaysia, but could also do any other developing country. Like that's something that we're responsible to have finished, actually have implemented in the model by March, I think.
Mm-hmm. That's right. So kind of with that, kind of just thinking about these country-specific applications and questions, for example, of what if a country has a large informal sector? That's not something that's been very important in current applications to the United States or the United Kingdom. But the idea is these country-specific applications, as a country is modeled that has some different feature that may not currently exist in OGCore, this, if it's again, a theoretical addition like multiple sectors or the addition of an informal sector, that would be something that one would add to the OGCore framework so that it could be available for any country-specific application. And then the country-specific models, what they'll do is they'll contain a specific calibration for that specific country. So for example, as we add these multiple sectors over the next several months to the OGCore platform, there'll be a new set of parameters. For example, the relative share of the informal sector in the economy. For the United States, maybe that parameter is a very small share. For India, it may be a larger share. But that country-specific calibration just contains the parameter value, but OGCore has the broader set of equations and parameters available to model that aspect of the economy very flexibly. All right, so again, some country-specific models, such as OGUSA and OGUK. These include links to country-specific microsimulation models from which OGCore fits parametric tax functions. So what this allows is the ability to look at very detailed tax policy proposals that can be modeled in this individual or payroll tax or consumption tax microsimulation framework, and then bring those policies into the OGCore platform, and thereby these country-specific models with a good bit of detail, a lot of the detail that's contained in those microsimulation models. So for example, OGUSA links to the policy simulation library cataloged tax calculator model. OGUK links to the PSL cataloged open fiscal UK model. And so that framework, that linkage between these microsimulation models is embedded in these country-specific models because, again, the interface to talk to these platforms varies and is not something that's general as OGCore is intended to be. Okay, so these country-specific models, again, we have a couple examples set up with the USA and UK frameworks, but the idea here is to have these country-specific models contain a JSON file that has the default parameter values. That's something you saw read in a prior slide to that update specifications method. But also these country-specific models will contain a series of scripts from which one can derive at least some of the parameter values that represent that specific country. So many of the parameters are estimated or calibrated. These scripts start with the raw data and show the process to calibrate or estimate those particular parameters. The model-specific applications also come with documentation, so parameters that are not done through estimation or calibration, parameter values that are just set as some default value, those would be documented in that documentation. Okay. Each of these country-specific models has a calibration class object that can be used to update the parameters and return them in a format that's suitable to pass to the OGCore specifications object. Okay, to provide a kind of minimal working example of that, here we are working with the OGUSA model. So we're having those imports from OGCore, the runner function, the specifications class object, and then we import from OGUSA the calibration class. What happens next, we instantiate a specifications object calling it P. We go ahead and update those specifications to the default values for the USA. Then the next line is looking at reform, an individual income tax reform, and that's in a format that's suitable for the microsimulation model OGUSA is working with, in this case, the tax calculator model. The following line instantiates the calibration class, passing to that calibration class in this case, both the parameters of the model as well as that specific IIT reform. There's an argument here, estimate tax functions equals true, which means go ahead and talk to that microsimulation model, run a simulation, and then estimate parametric tax functions from that. The results of that will come back in this C object. And then the following line, p.update specifications, is just going to take what the result of that, in this case, tax function estimation from that C object as a dictionary, use that to update the specifications object P. And then we pass those updated specifications, now including default values for the United States, as well as this change to the individual and payroll tax law by changing the Social Security earnings threshold. And we pass that to the runner function, and we go ahead and simulate. With that, we simulate this overlapping generations model under this change in tax law. All right. So again, just kind of highlighting here what OGCore is, this general framework. There's very detailed documentation going through all of the equations in the model, as well as the solution algorithm here to solve for the steady state, as well as the transition path. All of that is available at pslmodels.github.io/OGCore. And that includes instructions to get you set up and running with this model, as well as example scripts that you can build from. The OGSA model, which is the most well-developed country-specific model, also has a nice set of documentation, also pslmodels.github.io/OGUSA. Again, that's going to include instructions for running the OGSA model, an example script you can build from, as well as documentation about how that model works and is, in this case, calibrated to the United States. That repository, the OGSA repository, also provides a good template for creating new country-specific models, showing examples of how parameters are created from raw data, how the calibration class is set up in a way that works with the OGCore specifications object. All right, so I hope you go and read those documents, and if interested, contribute to OGCore or the other country-specific models, or develop a new one built off that OGCore platform. Okay, all of those repositories that exist, OGCore, OGSA, OGUK, are well monitored by Rick and I, and we're happy to answer any questions that you pose in the issues in those repositories. And if you want to build a new country-specific model calibration, we would be very happy to guide you through that process.
Jason, there were a few comments and questions in the chat. One of them was from Gabriela about, does the model allow for unemployment? I responded and said that there's no, of all the different types of households, none of them ever supplies exactly zero labor supply, but labor supply can fluctuate continuously between 0 and 1 based on policies and incentives that they face. Do you have any other answer you want to give to Gabriella?
Yeah, Yeah, that's right. We don't have an extensive margin here. That's pretty typical for this class of model, but we do recommend, at least with our default calibrations, using the appropriate Frisch labor supply elasticity that is representative of an economy like this, where there's no extensive margin of labor supply.
And then there's another question by Katerina saying, are there sectors such as manufacturing? How many? I think we already answered that. That's something that we're adding, and we'll be able to add as many sectors as somebody wants in a calibration. And but for these developing countries, we definitely want at least an informal sector and then a couple of more formal sectors. So I think probably a minimum number of sectors to run for a good calibration would be 3 sectors. And then there's a request for you to share your slides.
Yes, I will be following up this talk with a blog post at blogs.pslmodels.org. I'll provide a link to this video as well as my slides and some other information here. Gabriella, did you have another question? Feel free to unmute. All right, I saw a raised hand. But I'm glad, again, to answer any further questions. Again, you can reach me more specifically with questions through our repositories, OGCore, OGUSA, or OGUK. But I'm also glad to take questions via email, jason.debacker@gmail.com. But I appreciate your attendance today, and I hope you found this helpful. And again, look forward to seeing you around these repositories as users or contributors in the future.
I have a quick question. I think Gabriela asked a question, Jason, which again about tax calculator. So it would be nice if you can, just share on your screen the detailed model, because I think your OGCore page on GitHub has a lot of detail. I think that will be helpful for people to know, even just eyeball it to understand. And also, if you also have like a presentation which describes the model, how each of those different agents interact and what kind of, it's be good to see some kind of broad level, how the interaction of the agents and where the data is coming from. Okay, so that's one question I had. And the other one is about when you do calibrations, everything goes through JSON files. It doesn't go through a CSV file or something. I'm just thinking how complicated things like population dynamics. They also go through JSON files or through CSV. Thank you.
So it's the parameters object is kind of built to read from a JSON file. You could, of course, write your own script to read a CSV file into a JSON format. So that would be certainly possible. You'd add to my minimal working examples in those slides, probably one more line to turn your CSV into the JSON format and then read that in as a dictionary. Yeah. Yeah, but you're right. Those are, some of these parameter objects or specific parameters, I guess, for OGCore are quite large objects. As Sebastian mentioned, there's very rich demographics modeling the distribution across age from the current period to this very long run, which in the default calibration is more than 300 years. So you've got an object that's essentially something like 80 times 300 in dimension. So it's a fairly large object, and right now, again, those are loaded into the default parameters JSON files, but if one wished, they could, of course, store those in other data formats and then have those read in.
So Jason, I think one way you can answer Sebastian's questions, the ones about the model specifically, and then Gabriella's question in the chat about how the tax calculator works, is to just kind of give a quick walk through what the documentation. So you're sharing the documentation on your screen. Just give a quick walkthrough of what's in there.
Yep. Yeah. So right now I've pulled up that OGCore documentation. Again, this is all hosted on the web, pslmodels.github.io/OGCore. Rick posted links in the chat. Let me go down here. There's information just generally about the model. There's specific information about the application programming interface, what each function is in the model, what it takes as arguments, what it returns as a result, and so on. But let me go down to the theory here that outlines essentially the model equations. We got kind of the summary of what the structure of this model is at the introduction page. And then there are all the specific equations describing, for instance, how the population demographics evolve over time, how households make decisions and what constraints they're subject to. Here's the household budget constraint. We have the household's utility functions specified, and then their first order conditions for their choice of capital, or in this case, savings and labor supply. So all those equations are outlined here. And the model solution involves solving, under kind of the default parameter values. This is, you're solving something around 500,000 nonlinear equations when you solve this model because of those heterogeneous agents and the time horizon over which you're solving the model. Firms, production function here, kind of a general CES production function. We've again got the optimality conditions for firms. Governments, tax and spending policies, their budget constraint are all outlined. The model, in order to obtain a solution, we did a stationarized model. So there's a long run underlying growth rate. There's also population growth. So the stationary model solution involves stationarizing the variables that are growing over time. Details on exactly how that's done are outlined here in the documentation. And then the model solution algorithm as well is outlined here. So you can see exactly in words and equations what's happening in the underlying source code. Okay.
And will you show one more section, Jason, just in the OGUSA documentation, the tax functions? So jumping to a country calibration, this is where a documented interface of how the tax functions are brought in is.
Yeah, so now we're looking at the OGUSA documentation. So this is a specific country calibration now. So all of the equations that we saw in OGCore are going to be used, but here we've got documentation on, what are all of the parameters that are going to be calibrated? How do we calibrate, exactly the rate of time preference, elasticities of labor supply, and so on. And then, again, many other chapters here documenting other parameters, but let me focus on the tax functions with which Gabriela had a question. Here we're talking about those effective and marginal tax rates that enter into the household's budget constraint and first order conditions. So we're outlining here, like equation 19, this is something that essentially maps to the underlying theory documentation we just saw. And we talk about the underlying data that's used. In this case, it's the tax calculator model. That is a microsimulation model for federal income and payroll taxes in the United States. So we show some data, what the tax effective and marginal tax rates from that model might look like. We talk about how we're fitting those functions here to have a parametric functional form in OGCore that in this case matches what tax rates look like in the United States under a current law baseline or a user's chosen policy simulation. All right, so we've got the equations that represent those functional forms, description of what the various parameters are, some examples of model fit, in this case using a current law baseline, and details on exactly what the estimation routine is here. It's a weighted nonlinear least squares estimator that fits these parametric tax functions. OGCore allows for multiple different types of tax functions to use. So Rick and I, along with Kirk Phillips, developed a kind of ratio polynomials function that we believe does a very good job of modeling income and payroll taxes. We have a 2019 paper that's cited here that goes into very great detail about those tax functions and a comparison between those and others tax functions. But the model does allow one to choose alternative functional forms for those parametric tax functions, such as Duvay-Strauss, or if one wishes, and this is sometimes helpful in just simulating something very quickly, you can do just linear tax functions, so constant, marginal, or average tax rates. I should note that these, we can get into more detail if one wishes, but these functional forms for marginal and effective tax rates can be estimated separately by age to account for example, policies that vary by age, such as maybe older individuals receiving some tax preferences, or to capture the fact that, say, portfolios of capital income vary over age, and if those different sources of capital income are taxed at different rates, these tax functions, when they're age specific, can account for that. So there's a lot of flexibility in terms of the functional form one uses, as well as whether or not they want to use age specific or non-age specific tax functions, which may suit their case or be a compromise in terms of compute time, for example. So yeah, so that's kind of again a high level overview of how a model, in this case a country specific model, calibrated to the USA, interacts with a microsimulation model. For others, for instance, we've interacted with the Tax Policy Center's microsimulation model, and for the UK calibration, Open Fiscal UK. And again, all these functional forms I'm showing you here, and the estimator as well, all of that remains the same. You're just fitting to, in this case, different data to represent a specific country application. All right.
Thank you so much. I don't know if you can hear me now.
I can, yes.
Oh, great. Okay, sorry, my microphone wasn't working earlier. So yeah, I understand that you're basically putting into parametric format what could be very nonlinear sort of kinks in the tax schedule, right?
Mm-hmm. That's right.
Did I understand correctly?
That's correct. Yep.
Okay. So when you have a situation where you're playing around, or there's a reform that will play around with allowances and deductions and like very detailed policy changes, that's going to change the functional form, perhaps, of your polynomial or whatever. I'm wondering if you've ever done these models where you would actually go to the microsim, run the microsim, and then export, I don't know, an outcome from the microsim into the CGE. That's one question. And the second question is, I see that you're doing that on the tax side with the microsimulation. What about on the transfer side? Because often we have also very specific eligibility criteria that we want to model, changes in the eligibility criteria for social transfers. So I don't know if that's included somewhere.
Yeah, these are great questions, Gabriela. And on the first, on kinks in the tax schedule and so on, again, our parametric tax functions are smooth. That's kind of a necessary condition for solving these nonlinear equations. Also, I think it's a little more realistic in terms of how we're modeling the economy. We're not modeling hundreds of millions of individual agents. There are kind of groups of agents represented by their age, their birth cohort, and their skill level. And so you can think of, we're averaging over many individuals. So you're kind of averaging out these kinks, if you will. So that is, in some cases, potentially a limitation of the model, but in general, we probably think that those kinks aren't applying to large groups of people are not right at those kinks in the tax schedule. On your second question, with respect to spending policies, and yes, so for the United States, we don't have, at least currently, any access or even knowledge of an existing microsimulation model for federal spending policies. However, with the UK model, Open Fiscal UK does model spending programs as well. So that microsimulation model includes the ability to model spending changes. And so what comes out of the Open Fiscal UK model and is then fed into these tax function estimations that are part of OGCore are net tax transfer income. And so they're including effects on marginal tax rates, both from tax policy as well as spending policy. So we've got effective and marginal tax rates in that case that are representing the net of the tax and transfer system. So whenever, for any specific country, if there's the ability to have a microsimulation model for those spending policies, that's great. And it's certainly something that can be included in the OGCore model. We do, at least thus far, we've recommended including it in this net tax function. Again, because of the interactions between tax and spending policies, and then needing essentially some properties like continuity and monotonicity of these tax functions. We want to capture both the tax and spending together so that we can ensure that the resulting estimated tax functions satisfy those properties that are necessary for a model solution, essentially.
Let me just add one more thing here that Gabriela was saying, take results from a micro simulation model, run an experiment, and then bring that into the macroeconomic model. That's exactly what this is doing. One of the deliverables for the World Bank, in addition to multiple sectors, is more robust tax function estimation that allows for not kinks, but more ripples and potentially non-monotonicity in the tax functions. Like, this is a whole, I mean, we should probably just set up a training with the World Bank about all the ins and outs of what this tax function estimation is doing. But that one of the deliverables for the World Bank is a more robust tax function estimation, because when you add these benefit programs and transfer programs, you do see a lot of non-monotonicity in effective tax rate functions and marginal tax rate functions. And that, in terms of theory, that creates some difficulty in solving the model.
Jason, I think the question was, I think Gabriela also wanted to know about the micro simulation model, that where you could make changes and which then feeds into, interacts with our thing. So, I mean, as a background, we use the similar micro simulation model, Gabriela, that is being used by Rick and Jason in their model. It's from the same kind of background. It's just that the US microsimulation model is far more detailed. It actually integrates the household survey along with the tax IRS public use data set, if I know right. So for India, we had a similar microsimulation model that again interacted, was in sending those, essentially those data points to the model which generates those tax functions. So we do have any microsimulation model will again work very well with the current CGE model that is being used. And again, coming to tax functions, I mean, thanks for mentioning this, Rick, because one of the options we put in the tax function was the idea is to have negative taxes, in which case your tax function can also have negative effective rates, correct? That's a possibility, right?
That can currently be handled by the OGUSA tax functions, or OGCore.
Yeah, negative rates aren't the problem. It's just the issue is you need flat or increasing marginal tax rates, with decreasing marginal tax rates, decreasing over income, that can pose multiple, essentially there's multiple solutions to these nonlinear equations. Yeah.
Thank you.
Is there a question here from Katerina?
Yes, just a quick question. Thanks so much for all the previous answers. Really appreciate it. Just small question on the firm side. I know I should go and look, and now I know how to use the documentation that you have. But so there is one firm basically right now, right? So you have one sector and one firm. There's no heterogeneity on the firm side. Oh, okay. That's
right. Yeah, we are trying to take into account, at least with the USA calibration, we've been careful in terms of the corporate versus pass-through sector, and so this representative firm is kind of like a weighted average of those two sectors. But as we develop multiple sectors, those sectors will not include differences across industry in terms of what's produced, but also differences in terms of tax treatment. So you can think of there'd be a manufacturing sector for corporations, and then also a pass-through manufacturing sector if that were important in that country's context.
Then there's going to be as many models as sectors, right? So it's firms, sorry. So there's still going to be a representative firm.
A representative. Yeah. You got it. Okay. Yeah.
Okay. Thanks.
Maybe one last question. We at the bank are working a lot on climate now these days. So question is whether you can include climate effects somewhere in the model. So for example, including a damage function in the output function, putting in something. Do you have any of that in your modeling currently?
Currently, there is not. I think that's something that would be natural to add as we develop multiple production sectors, and there's kind of variation across sector in terms of its, for instance, greenhouse gas emissions. I think that in that case, that'll be something that'll be natural to add, and also because some of these obviously carbon taxes are going to have a different impact across those sectors. So as we develop those multiple sectors, I think that's when Rick and I will think hard about climate change policy in here, or in the OGCore framework. But again, we're glad to take suggestions or contributions, how you could add that with just a single production sector.
One more quick question, Jason and Rick, is to suggest to whoever are on the call today about how they can work with you, how they can work together, because it's something that is part of the project in the World Bank project. Yeah, thank you.
Yeah, it's a great question, Sebastian. So there's, as I mentioned, I think, as we've kind of developed these models, we've worked with a number of other contributors across, essentially at this point, across the globe. And there are certain challenges to working asynchronously with a large group of people. And so what we found is really helpful is to kind of establish a good workflow, a good set of version control strategies to keep code integrity high and keep issues that are important at the forefront. And with that, we've tried to use, therefore, Git and GitHub to really, facilitate contributions of code as well as communication. So let me put up a link to a repository here where we've been working with the World Bank. I just need to get the link up, and that is through the Revenue Academy, and the OGCore model is also there as well. So I'll put a link to that. And so that might be, for those in the audience from the World Bank, kind of a great place to have some communication with Rick and I, as well as Sebastian, who's helping to kind of manage this project. So in that GitHub repository, you can post issues where you could ask questions or make suggestions. The source code is all available for your viewing there, as well as links to the documentation that's been provided here.
I would add not just viewing, you can actually run it.
Yeah, you can download and execute the code. Yep.
But we've also had, for the last couple weeks, like an hour or hour and a half discussions with different subsets of people at the World Bank, and we're happy to continue doing that. And so, for example, Gabriela had questions about tax functions. Katerina had questions about different industries. We could spend, based on demand like that, we can spend time talking about the ins and outs of those different industries and the things that we're adding. And the greatest would be to have, as we're adding things like multiple industries, to have some input and contributions from other people at the World Bank.
And I'll follow up. I put a link in the chat. pslmodels.org/events has all the policy simulation library events, which are the public is welcome to. And I would encourage those of you at the World Bank who have an interest in the OGCore platform and some of the country-specific applications we're working on, to, if you're free, attend the OGCore developer meetings, which take place every other Monday at about this time, noon to 1 p.m. Eastern. And again, there, you don't need to notify us beforehand. Rick and I and others are on that call on a regular basis, kind of going over issues in the kind of development of this class of model. We'd be glad to have you attend any of those if you wished. All right. Well, again, thank you all so much for the questions and for your interest. And I look forward to hearing from you more in the future. All right. Take care,
Thank you,
everyone.
Jason.
Bye.
Thank you, Rick.
Thanks, Jason.
Thank you.
Thanks so much.
Bye.